welcome to The Explainer. Today, we're going to build a modern fortress. But forget about stone and mortar. Our tools are going to be things like policies, encryption, and a completely different way of thinking about security, all in the cloud. So let's get started and lay that first stone.
First things first, let's just get this out there. The cloud isn't some optional extra anymore. It's everything. It's the engine behind pretty much all of today's innovation, letting businesses scale up at a speed that was just unimaginable a few years ago.
Okay, but with all that incredible power comes a pretty huge challenge. The big question, the one we're here to answer, is how in the world do you keep all of your data, your apps, and your infrastructure safe from an ever-growing list of threats?
And yeah, those threats are real. Just look at this list. These are the 11 biggest security headaches in the cloud right now. We're talking everything from sloppy identity management all the way to organized hackers trying to steal your data. But don't worry, because we're about to walk you through the playbook to defend against every single one of them.
So, before we can even start building our defenses, we have to understand the ground rules. We've got to know exactly whose job it is to secure each piece of this massive cloud puzzle.
And that brings us to this, the shared responsibility model. Honestly, this is the foundational agreement for all cloud security. It spells out in black and white what the cloud provider, like Amazon or Google, is responsible for and what you, the customer, are responsible for. Getting this right isn't optional. It's the contract that tells you exactly where your job begins.
The easiest way to think about it is like renting a house. The landlord, that's your cloud provider, they're responsible for the building itself, the foundation, the walls, the roof. But you, the tenant, you're responsible for locking your own doors and windows to protect everything you put inside the house.
All right, so now we know what we're responsible for. Let's dig into our toolkit, starting with maybe the most important tool of all. This is all about controlling who gets the keys to the kingdom and what they can actually do once they're inside.
This is all handled by something called Identity and Access Management, or IAM. You can think of it as the digital bouncer for your cloud. It's standing at the door, checking IDs, and making absolutely sure that nobody gets into a room they're not supposed to be in.
Now, the gold standard here is something called role-based access control. So instead of giving access to, say, Bob, you give it to the developer role. This whole idea is guided by a really critical concept, the principle of least privilege. You only give the absolute minimum access someone needs to do their job and nothing more. Why is that so important? Because it massively shrinks your blast radius. If an account gets compromised, the amount of damage an attacker can do is kept incredibly small.
But, and this is a big but, it is so easy to get this wrong. So many companies fall into these really common traps, like just giving everyone admin-level access just in case, or completely forgetting to turn on multi-factor authentication. And every single one of these is a massive, gaping security hole.
So the key here is discipline. You've got to enforce strict rules, like making multi-factor authentication mandatory for everyone. And seriously, this isn't just a suggestion. Stolen credentials are the #1 way attackers get into the cloud, which makes MFA your single most effective defense. From there, you always use groups, you always grant the bare minimum access, and you watch your logs like a hawk.
Okay, we've secured the doors. Now let's talk about protecting the crown jewels, your data. It is, without a doubt, the most valuable thing you have in the cloud, and it needs to be protected no matter where it is. You see, data really exists in two states. There's data at rest, that's when it's just sitting there, stored in a database or on a hard drive. And then there's data in transit. That's when it's actively moving across the network between different services. The thing is, it's vulnerable in both states, and both absolutely require strong encryption. For most situations, you're going to protect that data at rest using what's called a Key Management Service, or KMS. This is basically a service your cloud provider offers to help you create, manage, and control the encryption keys that lock and unlock all your sensitive information. But for those times when you need the absolute highest level of security, we're talking banking, government, super sensitive stuff, you need to bring out the big guns. This is a Hardware Security Module, or HSM. It's a dedicated, tamper-proof physical box designed to do one thing and one thing only: keep your keys ridiculously safe. And this table just breaks down the difference perfectly. KMS, the software service, is all about managed convenience and making things easy. The HSM, that hardware box, is all about absolute total control and meeting the most hardcore compliance rules out there. So what about protecting data when it's on the move? Well, for that, we use something called Transport Layer Security, or TLS.
You actually see this every day. It's the technology that puts that little lock icon in your web browser. It creates a secure, encrypted tunnel for all your data to travel through, protecting it from anyone trying to listen in. All right, so we've got our access controls locked down and our data is encrypted. Now let's see how all these pieces come together to actually build the walls of our fortress.
You know, a good fortress isn't just one big wall, right? It's got layers of defense. It's the same idea in the cloud. We layer different kinds of network security controls, things like security groups, which are like firewalls for your individual servers, and web application firewalls, which protect against more sophisticated attacks aimed at your actual applications.
But this brings up a really critical question, one that changes everything about modern security. The old way of thinking was all about building a strong perimeter to keep the bad guys out. But what if they're already inside? What if you can't even trust your own network anymore? The answer is a whole new philosophy called Zero Trust Architecture, and it runs on one simple but incredibly powerful rule: never trust, always verify. It completely throws out that old, outdated idea of a trusted internal network. Why? Because in today's world of remote work and mobile devices, that perimeter just doesn't exist. So instead, you assume every connection is hostile until it proves otherwise. And this is the core idea, right here. In a zero-trust world, it doesn't matter if you're a user in the corporate headquarters or someone working from a coffee shop on public Wi-Fi. There is no inside versus outside. Every single user, every device, every connection has to prove it's trustworthy every single time. Now, the ultimate goal, the holy grail, is to make all of these security practices automatic and continuous. And you do that by embedding security directly into every single step of your development process, from the first line of code to the final deployment. That whole practice has a name: DevSecOps.
And that leaves us with this really clear and powerful mantra for modern cloud security. It's not about trying to bolt on security at the very end anymore. It's about designing your systems to be secure from day one, operating with the visibility to see absolutely everything that's going on. And once you have that foundation, you can scale your business with total confidence.